I would like to demonstrate my solution to day 24 of Advent of Code, the crossed wires circuit. And as you can see, my solution draws out the entire circuit visually upon startup, and it also immediately shows the puzzle answer in the top left corner. And the reason it can do that is because while drawing out the circuit, it spots anomalies in the pattern and marks these wires red, as you can see here. And we have another one a little bit further down, this one. And then obviously we have two more because there are 4 pairs of crossed over wires is the last one. But my solution can do a few other things as well. It can simulate the circuit in real time, and we can also test the device. The input values you see right now are those from my personal puzzle input. It's the decimal representation of the binary values of the X and Y wires, and the value of the Z wires when the circuit is finished will be shown in this text box after it's finished. But first let's start animating the circuit. What you see right now is the values being emitted by the wires, and initially that's only the wires from the that have a value in the puzzle input. But when we will click simulate, you will see that the other gates and wires are processed as well. So once a gate receives values from both inputs, it will process that and send the result to the output wire. So let's click simulate and see what happens. So you can see the values falling through, and also that the wires that are on the end of the circuit, the Z wires, will be highlighted once they receive a value. And also you see that all the values, all the bits going around are actually yellow, also in this area. I will get back to that later on, but first let's scroll down to the next pair of crossed over wires, because that's far more interesting to see. We'll see here, and it will take some time before the values actually arrive at these nodes. There they are. What you see is the connections and wires after the crossover wires are actually marked purple, and the bits are red. And what that means is that are the wires that are also influenced by the crossed over wires. So it's the actual impact of the crossing. These values are different because of the crossed over wires here. So not only FVW and Z18 have a different value because they are switched, but also these nodes following them have a different value. This effect, this impact, eventually also stops at a certain point. For example, over here we have the NRR node, which is emitting a 1, and that arrives at an AND gate. But because the AND gate receives its other value from MSM, which is emitting a 0, the output will never be true regardless of what the input from NRR is. So at this point the influence of the switched over wires stops. The amount of impact of a crossing is not only determined by the location of the crossing, but also by the input values. Let's scroll back to the first pair of crossed over wires. You can see that not a single value is red and not a single connection is marked purple, and that's because X05 and Y05 both have an initial value of 0. So it actually doesn't matter that we cross over these wires, and there's no impact of this crossing at all, which also makes it a little bit harder to find when you only look at the values that are incorrect. But these need to be correct to handle all different sets of inputs, as the puzzle description states. So when we scroll down a little bit further to the third pair of crossed over wires, you will see that the influence of this crossing is way bigger. It goes down from Z22 all the way to Z27. All of those bits are actually switched over because of the crossed over wires. And the last section is again a little bit different because this impact is much smaller. You only have a few values that are changed by these crossed over wires. So let's go back, and we'll see that now the device is finished processing all of the values. The output is shown here, and it is marked red because well, the test fails checking if the sum of these values is equal to the output of the device, which is what we expect the device to do. So it's not working correctly, and that's because of the crossed over wires. So now let's click repair. And what this does, it switches back the wires that it found are being crossed over. So for example, these two are now switched back and are in their correct location, and that goes for all of the other pairs as well. So the entire circuit is now looking the same from front to back. And when we now click simulate, you will see that the output is different and is now correct. This is the sum of these two input values, and you also will see that it is now animated to process these two values. We can also put in other values as well and test the device. And this also shows that why the input values determine the effect of the crossed over wires. If I were to put in such low values, low numbers, only the first few bits in the device are flipped to true, and actually with these values after wire 1, not a single bit is set to true. So any crossing that would appear after this point would not influence the output at all. So actually without repairing the circuit, 1 plus 2 would actually be 3 as well in my initial state. But we can also put in larger numbers as well. Let's try this. And you can see that it also works perfectly fine. And now a lot more bits are actually switched to a 1 further down in the circuit. So that's it for my solution. I've had a lot of fun building this, and mostly also building the visual representation. And I think the visualization of the impact of the crossing learned me a lot about what this puzzle is all about and why it's so interesting. Thanks for watching. And by the way, I didn't actually mention how I found these, because I don't want these crossover wires, because I don't want to include any spoilers, but that was on purpose. So if you want to see how I've done it, please take a look at my GitHub repository, and you can check out all of the code and the way I was able to find these values.